Hello everyone. In this video, we will learn to evaluate the constancy of the integrations. So let's go back and review the all the formulas that we have learned so far. Alright, okay. So in here, we have the integration formula, definitions, and also theorem. What we have is for any indefinite integral of a function raised to a power, and we learned these formulas already, and then we always attach the constant c because we are dealing with indefinite integral, and you see all of this is adding the constant c. And in this lesson, what we are going to learn is we will learn how to evaluate this constant c. So to evaluate this constant c, I would like to go back and review the concept of taking derivatives. Like I mentioned to everyone in previous lesson, is that derivative and integrations, they actually the reverse process of each other. So if you take derivative of a function, that means you are going to find the slope of the line tangent to a curve or a function as a given point. And then what about integrations? Okay, so what happens when the slope is given to you? If the slope is given to you, if you integrate the function, it will lead to finding the curve. Okay, so evaluate the constant of the given integration will give the result as the equation of the curve. So in order for us to do this, I would like to list a few steps so that we can follow when we want to solve for this example number 1 right here. So this example number 1 asks us to find the equation of the curve whose slope is given as this function square root of 6x minus 3. And this slope is actually passing through the point at x equal to 2 and y equal to minus 1. So let's go over the step up here. So first of all, you may want to write the equation as a slope, and the slope in this case is derivative of y as a function of x. Then you may want to write dy over dx equal to this slope. Alright, then what you do is it turns into like an equation. You can multiply dx over to the other side, and then you can take integration on both sides of this equation. So if you perform integration on both sides of this equation, is logical, is absolutely correct, is because integration is an operation in advanced calculus. So the basic principle with an equation is whatever you perform on one side of the equation, you do the same thing on the other side of the equation, and you don't change the equation at all. So in this case, you perform integration on both sides of this equation, and we already learned how to integrate, right? So you integrate both sides of the equation, but when you integrate, you make sure that you have to add the constant c. So after you have the constant c, given the values of x and y listed in this case, you can substitute x and y into your equation, and c becomes just an unknown in that equation, and you can solve for c. And then you can write the final equation of the curve in terms of x. Okay, so I just listed all the theory and explain all of this step for you, but then when I go over the example for everyone, I believe that it will clarify all of this step. Okay, so but we need to remember a few very important concepts in advanced calculus is that if we talk about the slope, it doesn't have to be that you just write m, the slope m equal to, because the definition of the slope is that you are finding derivative of a curve of a line tangent to the curve, and you evaluate that as a given point. So what does it mean by the slope? You can write it as dy over dx, okay? Differentiating this function in terms of its variable, which is x. And this dy over dx is actually a fraction, right? Because it's rise over run. So when it's equal to something, when your equation, you can always manipulate your equations. And if you manipulate your equation logically, you don't change the equation at all, and then you can perform integration on both sides. Okay, so let's get started with this example, and then you will clarify all the theory that I have explained for everyone above. Okay, so step number 1 is to write this equation. So because of the whole slopes here, I can write it as dy over dx equal to, this is the slope, 6x minus 3. Okay, so very logic in the logic actually proven itself in this case. Whose slope is equal to that. So basically you translate this into mathematical equations here, right? So it's a sentence, and then you translate that into a very logical mathematical equation. Then, as I explained to everyone, dy divided by dx. I can say that dy divided by dx. So I can multiply this dx over to the other side of the equation. So I can write square root of 6x minus 3, and I multiply dx over to the other side. So nothing wrong with doing this. And you probably ask me why you are doing, like, multiply this over to the other side of the equation. Because now I can apply my integration to both sides. So if I take the integral of both sides of this equation, I can solve for y and I can solve for x. Do you see here? You can, if I write the integral, okay, of both sides of the equation, integration is an operation in mathematics. So if I perform the operation on this side of the equation, and I do the same operation on the other side, I don't change anything at all. So now you can see that integral, when you integrate, the integral sign has to go with the differential factor. So in this case, you are integrate this in terms of y. And here, you are integrate this in terms of x. And we already learned how to integrate this. It is a function raised to a power. And you have the dx attached with your integral sign. You have dy attached with the integral sign. So in one of the previous lessons, I have mentioned to everyone that when you integrate a function, doesn't mean that you have to integrate in terms of x all the time. You can integrate this in terms of y as well. Alright, so then what I have is, and you probably ask me, there's nothing here, but it's actually a 1. Okay, so it's an invisible number 1 times dy, but I'm not going to write 1 in this case. So I can explain on the side for everyone here. I can put 1, but this 1 is a magic number 1. I can write it as y to the exponent 0, right? So anything raised to exponent 0 is equal to 1. And you asking me, why do you put y here? Because I want to create a variable where I can match with my differential factors of y. So I'm going to integrate this function y to the exponent 0 in terms of y. So then I apply the basic rule for integration. That means you add 1 to the exponent and then you divide it by the result of that. So 0 plus 1 is 1. And then y to the exponent 1 divided by 1. So this is just basically turned into y. Okay. So that's all the logic step behind having this dy and turn that into a y, because you actually integrate both sides, and then your number 1 times dy will turn into y to the exponent 0, and there it becomes a y. Alright, so I just want to make a note here is 0 plus 1 divided by 1. Okay, so just want to make sure that everyone remember that. Alright, so on the other side of the equation, you are integrate this function. So I'm going to write integral of the 6x minus 3, all of it to the exponent a half times dx. Okay, so as you recall, how do we integrate this? You are raising this function to certain power, so you have to let u equal to, right? So I'm going to let u equal to 6x minus 3 in this case. So this will be the integral of u raised to the exponent a half. But I have dx in this case, so I need to turn this into a differential factor of u. The only way I can do that is I have to differentiate this u in terms of x. So if I take derivative of 6x minus 3, what do I have in this case is 6. So what you do, you manipulate your equation. You bring 6 over to this side, you multiply dx to the other side, and after you do that, you have this as the exact match. Okay, so instead of writing dx, you are going to substitute this part here with du over 6. Okay, so now I will bring the 1 over 6 across the integral sign, and I have u raised to exponent a half times du. And you can go ahead and apply the formulas that given to you in previous lesson. Raise a function to a power, you add 1 to this function, and you divide it by the result of that. So if I take a half plus 1, I will have 3 over 2, right? So I will have 1/6. So I have to multiply by the reciprocals here. So u to 3 over 2 plus c. So divided by 3 over 2 means that I will multiply by 2 over 3. Okay, at this step, I can go ahead and simplify this. So this could be a 3. So I should have 1 over 9. Now you should write it as 6x minus 3. All of it raised to exponent 3 over 2 and plus c. And what is this actually equal to? It's actually equal to y. Yeah, so here is equal to y. Alright, so now you are having the equation of the curve as y equal to 1 over 9, 6x subtract 3, all of it raised to exponent 3 over 2 plus c. Okay, so originally this question is asking me to find the equation, and then it's giving me a point here, the coordinate on the graph, which is 2 and minus 1. So with 2 and minus 1, so here is the x value, so here is the y value. So what you will do in this case is you take these two values, you substitute into this equation. So I should have minus 1 equal to 1 over 9, okay, 6 times 2, subtract 3, all of it raised to exponent 3 over 2, add c. So now you see c is the unknown that you have to look for, okay, that you have to solve. So the c is the unknown that you have to solve, okay, in this equation. Okay, so then let me simplify all of this. So minus 1, so 1 over 9. In the bracket, what you have is you have 6 times 2 is 12, right? So 12 subtract 3 is 9. So you have 9 raised to exponent 3 over 2 plus c. So what do we have in this case? So we have 1 over 9. And 9 is 3 square. Okay, so to solve for this, you see that it's 3 square, 3 over 2. I multiply this 2 exponent. So 2 times 3 over 2 will give me 3. So that means it is times 3 raised to the exponent of 3 in this case, so which is 27, right? So I go ahead and try 27 here. So I will write times 27. If you don't want to work with this exponent algebra, you can just simply use your calculator. Take 9 raised to the exponent 1.5 using your calculator. It should give you 27 as well. But in this case, I want to remind everyone of this formula. Alright, Okay, so if I use this exponent formula, I raise this to exponent 2 so that I know that 2 times 3 over 2, this will cancel out, and therefore I will have it equal to 3 to the exponent 3, so that's why I will have 27. Okay, so it's just a reminder for everyone here. And how do we do this? 27 cancel with the 9, so I should have 3. So it means that I take minus 1, subtract the 3, plus the c, so c is equal to minus 4. Therefore, the question asked me to find the equation of the curve whose slope is equal to square root of 6x minus 3 and passes through 2 and minus 1. So the equation of the curve is the equation of the curve is y equal to 1 over 9, 6x minus 3, all of it raised to exponent 3 over 2, and instead of writing plus c, I will write minus 4. Alright, thank you everyone. Actually, not yet. I still have to work with the next example. Okay, so I believe I will have enough time. I probably will have 14 minutes to complete this for everyone. Okay, so now everyone kind of remember what to do, right? So you are going to translate this sentence into a mathematical equations. So slope is dy over dx, so I will simply write dy over dx equal to minus 1. And at the same time, I would like to raise this to the exponent as well. 1 minus 4x squared to the exponent half. Because I know that I eventually will have to integrate anyway. So that's why I prepare myself ahead and raise this equation to the exponent half. This should be x squared right here. Excuse me. Then your next step is to multiply the x over to the other side. Okay. And I also want to write it as minus x times dx. Okay. So you see, I just want to prepare myself one step ahead. That means that I know that I have to raise this to this function right here. As I raise this function to the exponent half, so I have to let this function equal to u. And this is my differential factor. I need to manipulate this so that I can replace with the du, the differential in terms of u. So now you know that you have to integrate both sides. Apply the integral on both sides of the equation. This will be y to the 0, and this turn into y. And now you can go ahead and integrate this part of the equation. So when I integrate this, I have to let u equal to, okay, so I'm going to let u equal to 1 minus 4x squared. Alright? Okay. So when I let u equal to 1 minus x squared, then I have to differentiate. So let me write it on this side. Okay. So I am going to write this as such. Okay. So I'm going to let u equal to 1 minus 4x squared. So you know right away that you are going to take du over dx. So then you will have negative 8x. So leave it for now because I will substitute this with the integral of u raised to the exponent half. Okay, and I need to have this form. So therefore, what I will do is I will take du divided by 8, and then I have negative x left, and I multiply the x over to this side of the equation. Now you see you have the exact match of negative x times dx, and this part is done. I already achieved my purpose. So I am going to write this as multiplied by du over 8. Okay, so I would like to pause for a few seconds and to remind everyone of this. So when you have the negative in front of x here, negative times x dx, many of us probably will bring this negative right across the integral sign, but you can do that as well. But what I did, I left it inside and I manipulate it from here. In the end, I know that I just have to multiply by du over 8 and no more negative sign to worry about, right? Okay, so here I can bring this as 1 over 8 and then u to the half times du. So you can go ahead, add 1 to this exponent, so there will be 3 over 2. Okay, so 3 over 2. If it's 3 over 2, that means you are going to multiply by 2 over 3. So then I will have the 1, 8 and u to the exponent 3 over 2 plus c. So that means I multiply by 2 over 3. I can simplify this by writing this. Cancel with that, I should have 4. So I should have 1 over 12 times u. So I am going to write it as 1 minus 4x squared. All of it's raised to exponent 3 over 2 plus c, and I will write the y right here, right? Okay, so now what you do is you're going to substitute the points that are given to you into this equation so that you can solve for c. So before we do that, we are going to double check that we have this equation correct, or else we will substitute the values into the wrong equation, then it's not a good idea. So we have all of that correct. So the point given for us is 0 and 7. So when x equal to 0, y equal to 7. So I can write it as 7 equal to 1 over 12. So you have 1 minus 4 times 0 squared. Right, okay. And all of this raised to exponent 3 over 2 plus c. Okay, so I have 7, 1 over 12. So I would like everyone to note this. 0 squared is 0. 0 times 4 is also equal to 0. So you have 1 raised to the exponent 3 over 2. 1 raised to any exponent is equal to itself again, which is 1. So in this bracket, I should have 1 left. Okay, so this is 1 over 12 times 1 plus c. So I just want to write 1 here so everyone will know that this entire expression inside this bracket is equal to 1. Okay, so I can just make a note here, is equal to 1. And therefore 7 now subtract 1 over 12 is equal to c. So therefore c is equal to 83 over 12, right? 83 over 12. So therefore you can make a conclusion. Okay, the equation of the function is y equal to 1 over 12 multiplied by 1 minus 4x squared. All of it's raised to exponent 3 over 2. Now add 83 over 12. Okay, let's double check. I think everything looks very good here. Okay, so the only thing I want to ask everyone is how do I get 83 over 12? Again, it's just a simple subtraction of fraction. You can use your calculator to work with, or I can get the common denominator. In this case, I take 12 times 7. I should have like 84 over 12. Subtract 1 over 12. So I should have 83 over 12. Alright, okay, just a quick note for everyone if you just want to do your fraction in your head. Alright, thank you. Again, I should remind everyone that I have a question here for everyone to try, and give it a shot and check the solution that I posted online. Alright, thank you.